Hello, so in this video we're going to look at Unit 4, non-right triangles. This section for Unit 4 looks at 8.1 and 8.2 of the Openstax textbook, first edition, and the link below. And there will be a link below to the first edition textbook online, and to the notes for this section. So let's look at some notes. So you're more than welcome to pause and write them down, or go to the shared folder in the link below and also follow along with me. So in the first row, we looked at, in Unit 1, we looked at the sides and need angles, where if you need a side of a triangle, you would use the top row, and if you wanted the angles for that triangle, you would use the bottom row. However, for those, you're looking more at right triangles, and that doesn't typically apply in these situations. However, it's nice to know them as well. In these situations, we're going to be given 4 cases where we're going to have an angle side angle, an angle angle side, a side angle side, and a side side side. And with any of them, we would have to find the missing sides of the triangle and then solve. However, that being said, we have formulas that we're able to use. For example, the law of sines. With the law of sines, you can see over here that we have a triangle labeled, so we know that angle A is across from side A, angle B is across from side B, and angle C is across from side C. And so when we create these law of sines, we can solve them as proportions. So we can create this long strand, and we can put them all equal to each other. So sine of angle A is equal to over A is equal to sine of angle B divided by B equal to sine of angle C over C. And so we don't typically have to use all 3. Let's say that we know angle A, we could say that we know angle A and we know side A and we know angle C. We could use sine of angle A over A is equal to sine of angle C over C. And so we know that we have an angle for angle A, so we're just going to put that as theta for right now. And we have length for A, we're just going to make it a pound sign or hashtag symbol. And we know we have an angle for angle C, and we'll put that as theta at the moment. And for C is what we're going to be looking for. And so we'll just cross multiply and solve, plug it into our calculator, and we'll get a value. We are only within the side angle side cases to find the actual area of that triangle. Because within the area of a triangle, we know that it's half times base times height. And so we can use that similar thing with these formulas that we're given. Next, we have the law of cosines, and for those cases, we have the side, 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 and then with this side, angle, side. And these formulas can be used pretty much interchangeably. It just depends on the type of triangle you have. Sometimes you can use them both. So where if you solve with law of sines first, then you can use law of cosines. So let's look at some examples. You're more than welcome to pause, solve them out yourself, and then see if we get the same answers, or follow along with me and get some notes. So for this example, we are solving the triangle with measure of angle A equaling 30 degrees, measure of side A equaling 11 centimeters, and side B equaling 17 centimeters. And so in this case, we're looking for angle B, angle C, and side C. So first, I would solve for angle B, because we know that we can use law of sines because we're given a angle A and side A, and we can use it with angle B and side B. So for angle B, so we're going to use sine of angle A over A equaling sine of angle B over B. We know that for angle A, we know that that's 30 degrees. So we can have sine of 30 degrees over A being 11, which is equal to sine of angle B, which we're looking for, over B being 17. If we cross multiply, we can do 17 times sine of 30 equaling sine of angle B times 11. If we divide by 11, we can get sine of angle B is equal to 17 times sine of 30 all over 11. And since we want our angle, we would use our sine of -1 and then put that all in parentheses and plug it into our calculator. And when we plug that into our calculator, we get approximately 50.6 degrees. Next, we want to find side C. But since we know that a triangle is equal to 180 degrees, for angle C, we're able to take 180 degrees minus one side that we're given, 30 degrees, minus the side that we just found, 50.6 degrees, plug it into our calculator, and we will find that angle C is equal to 99.4 degrees. For side C, we can take the sine of angle A and equal to the sine of angle C, and we can solve, cross multiply, and we can get our side angle back. So we can use the sine of angle A over A is equal to the sine of angle C over C. We know that angle A is equal to 30 degrees, side A is equal to 11, side C we found, angle C we found was 99.4 over C. If we cross multiply, we will get C times sine of 30 is equal to 11 times the sine of 99.4. If we divide by sine of 30, C is equal to 11 times sine of 99.4, all divided by sine of 30 degrees. Plug that into your calculator and you will get approximately 21.7 centimeters. So next we're trying to solve the triangle with the measure of angle A being 36 degrees, the measure of angle B equaling 24 degrees, and the measure of side B equaling 16. So we know that we want to find angle C, we want to find side A and side C. I would find the missing angle first, and we know that for the missing angle, we can take, since we know that a triangle is 180 degrees, we can take 180 degrees minus the two sides that we were given, 36 and 24. If we plug that into our calculator, we will get 120 degrees. Next, I would find side A. And if we look at the law of sines, we can use sine of angle B over B equaling sine of angle A over A. We know that the given angle for angle B was 24, so sine of 24 over B, which is 16, is equal to sine of angle A being 36 over side A is what we're looking for. If we cross multiply, we get A times sine of 24 is equal to 16 times sine of 36. If we divide by sine of 24, we get that A is equal to 16 times sine of 36 all over sine of 24. And when we plug that into our calculator, we get approximately 23.1. Next, I would find side C. And so we could use the law of sines again, or we could use the law of cosines. It should give you the same answer. So if you look at using the law of sines, we can use B over sine of angle B, which is equal to C over sine of angle C. We know that for angle B, we know that it's 24, and for side B, it is 16. So 16 over the sine of 24 is equal to C is what we're looking for, all over sine of 120 degrees. And if we cross multiply, we will get 16 times sine of 120 is equal to C times sine of 24. And if we divide by sine of 24, we will get C is equal to 16 times sine of 120 all over sine of 24. And if you plug that into your calculator, you will get approximately 34.1. So next we want to find the area of the triangle, and for these types of equations for trying to find the area, we know that we want a side angle side. And so for given, we know that side A is 11, angle B is 75, and side C is 8. And so we know that we have a side angle in a side triangle. So we're able to use that list of formulas that we're given. So we know that when we're given angle B, we are going to use the equation half times A times C times the sine of angle B. So we know that our triangle, our area, is going to equal a half times 11 times 8 times sine of 75. If we plug that into our calculator, we are going to get approximately 42.5 as our area. So now we want to solve the triangle, given that side A is 8 feet, side B is 19 feet, and side C is 14 feet. And just as a tip, as a good tip when you're solving a side triangle and you want the angles, typically the biggest angle is across from the biggest side. So let's find angle B first, and we can refer back to our law of cosines and see that cosine of angle B is equal to a squared plus c squared minus b squared all over 2ac. And so for a squared, we can see that it's 8, so we'll get 8 squared plus 14 squared minus 19 squared all over 2 times 8 times 14. When we plug that into our calculators, we get negative 101 over 224. And if we want the angle, we're going to do the inverse. So we will do cosine -1 over -101 all over 224. And that will give us an angle of approximately 116.8 degrees. So next, I want to find angle A, and I'm going to use the law of sines because I feel like it's more faster and it's more efficient. So we know that we want sine of angle A, which we have not found yet, and for side A, we know that it's 8, and we're going to set that equal to sine of angle B, which in angle B we found was 116.8 all over side B, which is 19. If we cross multiply, we get sine of angle A times 19 is equal to 8 times sine of our 116.8. And if we divide by 19, we get sine of angle A is equal to 8 times sine of 116.8 all over 19. Since we want the angle, we'll do sine of -1 over 8, all in parentheses, 8 times sine of 116.8 all over 19. And when we plug that into our calculator, we will get 22.1. And in order to find angle C, we can take the values that we found and subtract it from 180, and we will get the measurement of angle C. And when we plug that into our calculator, we will get 41.1 degrees.